Basic electrical wiring.
Hello gentlemen, today we are going to discuss about the resistance calculation for LED bulb, and in this lesson we will find out how to calculate the resistance for LED bulb, and also we will calculate that how we can find the power rating of resistor. So we will learn about the power rating to find out the power rating of a resistor, and also what should be the value of resistor for any circuit, for LED or any type of bulb. Now let's start the topic, resistance calculation for LED bulb. So here in this situation you can see there is a 12 volt battery and also 12 volt bulb having a 6 watt power rating. So if we switch on the bulb or the circuit, the current starts to flow and the bulb will glow. That is a normal circuit. But if we change the situation here, and in this situation the battery having the voltage of 24 volt, which is double voltage from the load, and the load having the voltage of 12 volt. So 12 volt the bulb voltage and 24 volt is the battery. So when we will close the switch and complete the circuit, the current start to flow, but at that time due to the flow of heavy current the bulb will blow up. So it's mean the 12 volt is much enough, so we must drop the voltage with the help of resistor. And what should be the value of resistor? So let's start the calculation that how we can find the resistance value of that resistor. For example, in this circuit diagram we having the voltage of 20 volt battery and having the load which having the voltage of 6 volt, and the power of that bulb is 6 watt, and we have to find out the resistance value of that resistor. So there are three type of voltage. One is the voltage which is a supply source voltage. The second one is the voltage drop against that resistor, and there will be another voltage which is going to be dropped by that load, that is a 6 volt. So here we will apply the Kirchhoff voltage law. As we know, Kirchhoff voltage law, in a series circuit the algebraic sum of all the voltage drop in the circuit must be equal to the source voltage. So as per the equation of Kirchhoff voltage law, we will write that the source voltage is equal to voltage drop 1 plus voltage drop 2. In our situation the source voltage is 20 volt, voltage drop 1 is voltage drop against the resistor, and the voltage drop 2 is the voltage drop against the bulb. So we can write that Vs is equal to V1 plus V2. So here is the equation, Vs equal to V1 plus V2 as per Kirchhoff voltage law, and that is V1, and as per Ohm law we can write that V1 is equal to I1 R1. So with the help of Ohm law we will replace the V1 with the I1 and R1. Now our equation will become Vs is equal to I1 R1 plus V2. Now here we will rearrange the equation by moving the value from right to left, and the equation will become R1 is equal to Vs minus V2 divided by I1. So that is our equation. Now in a series circuit, as we know, the current in a series circuit remains same because the circuit is series, and as we know I2 is the current of the bulb. So we will find the current of the bulb with the help of power formula. For the bulb, P is equal to Vi, and as we know the power of the bulb is 6 watts and the voltage of the bulb is 6 volt. So I2 will become 6 divided by 6 is equal to 1 ampere. So if the I2 is 1 ampere and the current remains same, it's mean I1 and IT also 1 ampere. So in this situation we can write the equation that R1 is equal to, by putting all the value, that as we know Vs is a supply voltage, that is 20 volt, and V2 is the voltage of bulb, that is 6 volt, and current, that is 1 ampere. It is calculated from that equation, it will become 1 ampere. Now by solving this equation with the help of calculator, we will find that 14 volt divided by 1 ampere is equal to 14 ohm. So in this situation, the resistance of this circuit which we have calculated, that is 14 ohm. Now the resistance of that resistor for this circuit is 14 ohm, but there is not only the resistance is required, we must know the power rating of that resistor, and for the power rating we will use the power formula, that is a 3 power formula for electrical power, but we will choose the second one, that is power is equal to I square R. So power is equal to I square R by putting the value of I, as we know the value of I is 1 ampere. So 1 ampere, that is 1 square multiplied by 14 R, that is the resistance of resistor 14. By the calculation we will find 14 watts. So the power rating of that resistor which is used in this equation should be 14 watts. So that is the formula which we have derived, that is R is equal to Vs, the voltage, minus VL, that is the load voltage, divided by the current I. Now we have the example 1 in this equation, and this example you can see the battery voltage is 4 volt battery, and we have to find out the resistance, and that is the situation, that is we have a LED having the operating voltage of 1.8 volt, and the current of LED is 20 milliampere. Now let's start the calculation with the help of same formula, that is R is equal to Vs minus V2 divided by I, and by putting all the value, that is Vs is 4 volt, V2 is 1.8 volt, and I is 0.02 ampere. By further calculation we will find that the resistance of this circuit should be 110 ohm. And now we will find out the power rating of that resistor, again by using the formula of I square R, that is power is equal to I square R. Now by putting the value in this formula and after calculation with the help of calculator, we will find out the power of that resistor should be 0.044 watts. So there is another example. In this example we having a 9 volt battery, and there are 3 LEDs which we want to connect to that battery, but what should be the resistance for the safe operating of that LEDs? Now again we will use the same formula, but before going toward the formula we having a chart. In this chart there is the different colors of LED having a different type of voltage. So as we have using the LED of white LED, so the white LED having a voltage of 4 volt. The operating voltage of white color LED is 4 volt, and the operating voltage of a red color LED is 1.8 volt, and the operating voltage of yellow LED is 2.2 volt, and the current for all LEDs is almost 20 milliampere. So the current for all LEDs is the same, but the voltage of all LEDs are the different. Now we will find the resistance for that circuit. Now once again we will use the same formula, that is R is equal to Vs minus V2 minus V3 minus V4 divided by I, and as we know this formula is derived from the above, and that formula is derived from the V1 minus Vs minus V2 minus V3 minus V4. So that is the formula, that is V1 is equal to supply voltage minus V2, that is the voltage of white LED, minus V3, that is the voltage of the red LED, and V4, that is the voltage of yellow LED, and V1 is the voltage which will be dropped against the resistor. Now by putting all the values from in this equation and after calculating, we will find the result. And one thing is, we have to know that 20 milliampere will be converted into ampere and it will become 0.02 ampere. Now after the calculation, it's become R is equal to 1 volt divided by 0.02 ampere is equal to 50 ohm. So the resistance for that LED after the calculation should be 50 ohm. And what should be the power of that LED? The power, once again, as we know, the current is 0.02 ampere and the resistance is 50 ohm. So by putting the value in this equation and after calculation, we will find that the power for that LED should be 0.02 watts. So in this circuit, the power is 0.02 watts for that resistor and the resistance should be 50 ohm. So you can use this formula for any type of circuit in which you want to drop the voltage. For example, you want to operate different type of loads and you want to know that what should be the value of resistor to operate this fan with the help of 24 or 12 volt battery. So you can put the value in this formula and can find out any type of resistor for any type of circuit. If this video is helpful for you, like and share the video and subscribe the channel. Thank you.
Basic electrical